This is the Earth Science Classroom. Welcome back. This is minerals, and this video is an introductory video about minerals, the foundation of geology, and why we do this. Well, we're looking at minerals as a foundation to forming rocks, and as you see by this beautiful image of the Earth taken by NASA, called the blue marble, taken from the moon. If you take away the atmosphere, take away the oceans, what you're left is the continents, the ocean floors. You really have the Earth's crust, and you have this large rock made of different layers, different compositions, densities, types of rock, but really it's a big rock that is flying through space around the sun. It's the third rock from the sun, and it's a terrestrial planet, so it's made of rock. And I think we forget that sometimes, that we take for granted that geology is this not very exciting study, but without geology and without rocks, we wouldn't have a planet. We wouldn't have our modern day society. We wouldn't have what we have today in our technology and our use of fossil fuels and transportation and industry and commerce and trade and all that good stuff. So also, you got some nice pictures here of some minerals. You got some nice quartz crystal here and some gold, native element right there. You got some gypsum, which is a cool mineral usually found in caves. You got another beautiful variation of quartz right here. You got some pyrite, which is fool's gold, and you got some magnetite, which is magnetic. So this video is going to establish and define what a mineral is. Also, we're going to look at why minerals are so important to human geology, which is kind of like what I just mentioned before, and the intro to atoms, to basic chemistry, and how these minerals are formed by the arrangement of different atoms and elements, and then how to group these minerals, because there's so many, there's over 5,000 different minerals, so we've got to group them together, and then we just discuss the characteristics and in particular their crystal structure, how they form in different shapes and patterns that are repeatable, and this is called the habits. So the shape of a crystal or mineral is called the habits. We're going to discuss this in this video. So why do we care about minerals? Well, minerals, again, are the foundation of rocks. They form... most of them do form rocks, some don't, some just stay minerals. And rocks are essential to our everyday life. We build with them, we find different resources within the rocks, we can understand the age of the earth and the history of the earth through rocks. We use minerals, or the understanding of minerals, the education of minerals, the science of minerals and mineralogy have enabled us to use ores, which is basically minerals that we can use for a certain purpose, like iron ores or various other things. And we use these characteristics of certain minerals to use in our everyday life. And we have the continued education of minerals has allowed us to progress society. For example, the Stone Age, right? The cavemen, Neanderthals, who would find certain stones and that you could sharpen to become tools or become weapons for protection or go hunting. So the hunter-gatherer age, you'd use these materials that are around in nature, basically rocks, to go and hunt animals to feed themselves, then to kill the animal and use the animal's fur as warmth, and then to create fire using certain rocks like flint that you'd whack together and knock together and create sparks, and again you create fire. So rocks and minerals really were the start of human progression and the understanding of minerals and such in soil to form agriculture and irrigation, to feed the population, to grow population, from early empires to what we have today. So really, and now even today, we use all these minerals in different forms of tech and appliances and cell phones, for example, which every teenager can't live without, is their cell phone. So what is a mineral? A mineral basically consists of 5 characteristics. So the first one, it has to be naturally occurring. Okay, so The second one has to be solid. It can't be a liquid or a gas or plasma. It has to be solid and naturally occurring. Okay, the third one. It must be inorganic. That means non-living, not alive. Okay? The fourth one. It must have a certain or specific or definitive chemical structure or chemical composition. That basically means elements and atoms. It's made of certain elements and certain atoms. Okay, fifth one. With all these naturally occurring, solid, inorganic, chemically composition, looking at the crystalline structure. Now, when you see the word crystalline or crystal, you think mineral. And the structure, that basically means the shape, okay, and the pattern at which the elements or the atoms are arranged in. So these certain elements and atoms, based on their electron configuration and where the electrons are and how these elements and atoms bond together and stick together, that would create a certain shape. Therefore, it would create a certain pattern or structure that only occurs with minerals. And each mineral has their own structure and their own chemical composition. So these three are pretty much the generic three. And then obviously the next two, chemical and crystal, they have to have that, but they can vary in the elements and atoms that make up each mineral, and it can vary or change the different kinds of structures that can be made with these different minerals. So there's over 5,000 different minerals that scientists have established and looked at, and these are made up of different elements, and which are basically a series or one of an atom, which occur in different patterns. So let's look at the atom. Okay, so looking at basic chemistry. Okay, the atom has a nucleus, which has a proton and generally a neutron and an electron that's flying around the outside, right? Now, there's different models to show this, but we basically need the proton, the neutron. So proton is positive, neutron has no charge, or let's say zero. I'm going to not use that little dash there, just put 0. And the electron is a negative charge. This is a charge. Charge meaning electrical capacity, right? So charge. So there's the atom, right? There's the atom. And if you think of it as in terms of Lego bricks, right? A smallest atom, which is hydrogen, or the smallest element, which is hydrogen, has atomic mass of 1, right? So that equals 1 Lego brick. If you want to have 2, which is helium, now this is the atomic mass, so this is 1 proton. Proton times 1. 1 Lego brick. You want helium, you just add a second brick onto the first brick. So you got 2 bricks, so the 2 protons. Times 2. Now, the largest naturally occurring element, there's 92 of them. Well, some researchers say 92 to 98, but 92, which is uranium, which is U as the chemical symbol, right? And hydrogen is H as a chemical symbol, and helium is He. So uranium has 92 Lego bricks, or protons. It's a very large atom, so you just add in Lego bricks, right? Add in bricks on bricks. So the amount of protons equals the amount of electrons. If you want to find the neutrons, you just basically subtract the atomic mass from the electrons, and you have the neutron. But that's basic chemistry. So these atoms form different elements based on the size and the amount of electrons and how they bond together. If they're stable, they usually stay by themselves. If they're unstable, they want to join with another atom or element to become stable. Uranium is very large, so it's very unstable, and it breaks apart. So some of the Lego bricks break apart and fall off, and we call this radioactive decay. When the Lego brick breaks off and falls off, it's called decay, and this happens on a organized and certain time scale. So out of the 118 elements, 8 elements are important that we really look at. Now, 99% of all the minerals on Earth are made of these 8 elements that are listed below. So you've got 1 through 8, you've got oxygen, all the way down to sodium. So oxygen, as you can see, is nearly half of the Earth's crust, and the Earth's solid layers is oxygen. Now, this is a gas, but it's very unstable, and it's kind of formed that way, and it's very easily bonded. So it means joined up with other atoms. So it quickly joins up and connects or bonds to other elements and other atoms. So it's very sticky. Water is. Well, oxygen is. I say water because it's very easily connected to hydrogen, which makes water. So, and the next one is silicon. Silicon, 27%. So together they equal basically 72.4%, these two alone. And then the rest are smaller percentages. Aluminium or aluminum is 8, iron, calcium, magnesium, potassium, and so on. So these 8 form 99% of all minerals found on Earth. So there are some rare ones that have other elements, but these are the common 8. So this would be our chemical composition as one of the 5 characteristics that make up a mineral. A mineral has to have a certain or specific or definitive chemical composition made up of mostly one of these 8 different elements listed here. Now, the most common is oxygen and silicon. So when they are combined, they form SiO2. So you've got the Si, which is the silica, and the O2, which is oxygen, and this equals silicon or quartz. And there are variations of quartz based on what else you add into the silicon and oxygen. So you can add different elements into the SiO2 and you can change the color or even the shape of the quartz. So when you establish a certain chemical composition, what you can do is all these different minerals is at least 5,000 minerals that have different kinds of combinations or singular elements or atoms inside of them. You can actually group them into just seven groups. All right, so the main one is silicates. Silicates is very important because they're the most common. And there's over 1,100 minerals in this silicates group. Now, silicates basically means that the chemical composition of that mineral must include silicon or oxygen to be called a silicate, right? Okay, so oxides, again, has to have oxygen. Carbonates must have CO3 in the formula. So in the chemical formula, you will see somewhere CO3, and that makes it a carbonate. Halides is salt or chloride or chlorine in the formula, or there's other ones as well. Phosphates is PO4. Sulfides is just sulfur, 2 sulfurs, so 2 times sulfur. All right, in the chemical formula. And sulfates, you get the combination of oxygen inside with the sulfur and 1 sulfur, so 1 times sulfur and 4 times oxygen, and that's what it looks like, SO4. So each of these different groups will have these as these elements inside their formula. Now, native elements, these are cool. These only have one, so gold is a great example, just Au. That's it. As you can see, a lot of these in oxides, because oxygen is very unstable, as I mentioned before, oxides will bond very easily with other elements, so they don't stay native. They don't stay just oxygen. They combine very easily. So oxides are very important for geology and atmospheric science. But native elements like gold, they stay only one. They stay by themselves. Why? Basically because they're very stable. They're a stable element, an atom, whereby they don't need to join up with another element to become stable. They already are stable. They're naturally stable. So they're also naturally rare. You don't find these too often in various places. So gold, silver, platinum, diamond, graphite, these variations of carbon. Diamond is basically carbon in a certain shape, same as graphite. Now, graphite you use for your pencils to draw with, and it breaks easily, but diamond, you change the shape, a little bit of carbon, you get diamond, which is the strongest natural element on the planet. So again, it's just the structure and the way it's formed which can change dramatically the outcome of the element. So native elements are awesome, but these 7 right here are the main groups, and silicates is really the only one that we care about, really. That's the main one, the most common one is silicates. All right, now, so we've discussed the chemical makeup of these elements in detail. Now looking at the chemical, the structure, the crystalline structure. So, crystalline structure. As I mentioned before, crystalline, you think mineral. Structure, you think shape. And this is controlled by what elements each mineral is made up of or composed of, and how they bond. And when they bond, they form different shapes and different structures. So the 7 main shapes are listed here, from isometric or cubic, which is the most common, to the cool ones like hexagonal, triclinic, tetragonal, orthorhombic, monoclinic, and over here the trigonal or rhombohedral, which is cool. So basically, these different shapes, they're formed through what's called the axes, okay, which there are either 3 axes. Okay, it's the X, the Y, and the Z axes, or there's a 4th axis, which is W. And what I mean by this is, look, if I do a little line here, this straight line here, that's one axis, okay? That's the Z. This one, I'll do a different color, purple. This one's straight up here, okay, is the Y, okay? And let's do yellow. Okay, and there is my X. So I have my 3 different directions in which the shape is going to form this 3-dimensional shape. And these are called axes. Okay, and the 4th one is over here on hexagonal. Here's our 4th axis over here. So you have your X, you have your Y, you have your Z, and you also have this one here, which is your W. So there's 4, which forms this hexagonal shape, which is awesome. So the cubic is the most common, but then what you have is also the different lengths can be, these lengths are all the same. So the lengths of the sides can be all the same, or one different, or 2 different, or all 3 different, and that can change the shape. Or you can also have the angles. The angles can be either perpendicular, like with the cubic, they're all perpendicular, right? So boom, boom, and boom, they're all perpendicular, okay? Or you could have some with a couple of perpendicular angles, or you could have one with no perpendicular angles. It'll be here. So this one here, triclinic, would have no angles that are perpendicular. I'm going to put perpen. right there, no angles. So it's kind of like a slanted kind of three-dimensional shape. It's slanted cube, basically. So these are the different kinds of structures that you can find. The most common you find minerals forming in that have their certain chemical composition, that are inorganic, that are solid and naturally occurring, and that's it. You have a mineral. And these minerals are essential for geology. It's like the ABCs of language, or learning your times table and your basic math when you're a kid. This is the basic stuff, the intro to geology, and this forms everything from volcanoes to plate tectonics to geologic history to fossils to find out even how to create nuclear energy and all of the different high-tech stuff we do from that. So these are pretty awesome stuff. And thanks for listening, guys. And you want to leave a comment? It's great. Subscribe, even better. And thank you so much.